So I see you're all enticed by the thrilling world of file uploads. Like many of the speakers probably, yesterday I had a plan. I thought I'll get some dinner, I'll go up to my room, have a look at my slides, make sure everything's okay, and then I'll be fine. But, as I'm sure you know, there was a power outage. So I still tried. I went up to my room with my head torch on, and 12% battery. I was like, this isn't working. So I looked out the window, and I was impressed because, you know, once the power was out in the rooms, I looked over the conference center, which was empty, but all the lights were on. So I'm glad the power was being used. And I was thinking the generators must be working overtime. There is no way the Phoenix generators could power a hotel. So this is the second talk in what I imagine is a thrilling trilogy of LiveView Talks. It's kind of the Die Hard 2 of LiveView Talks. I have no idea what that means. So let's start. If maybe this is your first day on the internet, or you've blocked Chris McCord because you're not interested in woodworking, we can cover what LiveView is. Not that. So it's a way of building rich client-side applications that you typically build in JavaScript, maybe using like jQuery or a front-end framework. But we don't have a requirement on userland JavaScript. So it uses JavaScript, but you don't have to write it, which is good for certain use cases. And the way you use it is you have a handle event function, and you'll receive events over a WebSocket. And then every time one of these events does something, it will re-render if necessary, and it has like a diff, so it only re-renders what's changed. And it looks something like this. So there is, you use the Phoenix LiveView, and then this is an LEEX template, which is like EEX with diff tracking. And we have a count here, which is the val. And we have two events that are attached to the PHX click. We've got a decrement and an increment, and then the handle event functions here, and it changes something on the socket, which triggers a re-render, and it's like a loop. So the goal of file uploads is to have rich client-side uploads with no requirement on userland JavaScript, so you don't have to write the JavaScript. And again, handling it with the familiar events on the back end using handle event. So one of the ways we can approach this is to use like a sideload. So we have the LiveView, and we do an HTTP upload with a file, and then when it's finished, we like get the data about it and tell the LiveView that the file's finished, and then the LiveView can go and fetch the file, and it'll be on the file system somewhere, and it can trigger the user event, and the user can do whatever they want with the file, and we're done. So if you prefer a diagram format, the blue line here is the HTTP upgrade, which becomes the WebSocket, which is the LiveView channel, and the HTTP upload is going off to the side there. And from an LiveView perspective here, it looks like this. We have the file input, and then here I'm just saying if the avatar's been set, then we'll have the file name, the MIME type, size, and then I'm using the data source on an image to use base64 to render the image. It's probably not something you do often, but it works just for demo purposes. And then we have the handle event, save event. So it's the same event you'd have on any form validation. And if the avatar is present, we can just assign it. And we're done. So thanks for coming to my talk. There's a problem. So I don't know if you've ever built an application and maybe you need a rate limiter, and you've decided ETS, that's pretty good, or maybe if you're using a newer version of Erlang, you can use the counter module, and you're like, well, I'll just have a count every time there's an API request, and I'll increment it, and then periodically I'll just reset the count, and when you hit the limit, your requests are rejected, and then when it resets, you can continue. And this works, and you deploy it, and it's great, and then you get a lot of traffic, and you're like, right, let's go multi-node. And you know, Phoenix, horizontally scalable, you just add more nodes and it works. Until it doesn't, you add your node behind the load balancer, and then you realize that everyone can make twice as many API calls because each has like its own local ETS or count. And that's kind of what's happening here. So there's two problems. One is that a plug upload is short-lived. So if you do it over HTTP, when the HTTP connection dies, plug will free the file from the file system, and you won't be able to access it. But the bigger problem here is the asset reconciliation on multi-node. And again, I have a diagram. So on the left here, we have the HTTP upgrade, which becomes a LiveView channel. And then we have the HTTP upload on the right, and that goes to a different node behind the load balancer. So by the time the LiveView says, hey, the file upload's complete, it's like, OK, I'll go get it. And it's on a different file system on a different machine somewhere else, and it won't work. But we do have a way to target where the file lands, and that's WebSockets. So what we can do instead is upload the asset over a WebSocket. It's an existing persistent connection to the server, and Phoenix channels are multiplex, so we can have like a separate channel for the uploads. So that sounds like a good solution. So the first option is we do what you always do when you want to send binary data over a textual medium, is you can base64 encode it. So what we can do here is serialize the form, read all the files, base64 the contents, and then gather all the files, send that up to the server, and then when you've got the form data there, we'll also have the file in there. We can base64 decode it, and then trigger the event on the LiveView. We could, no. So the problem with base64 is that there's a 33% overhead, and also it's going to block the channel, right? If you've got like a big binary that's been base64 encoded, sent over, it's going to block the channel. Here's a fun aside about base64. So each digit in the base64 language is 6 bits, and that's like A to Z, lower and uppercase, and 0 to 9. So for each 4 base64 digits, you can fit 3 bytes, and that's where you get this 33% overhead. And it's also why sometimes you'll see a base64 string encoded with 1 or 2 equals at the end, because it hasn't ended on a 3-byte boundary. I told you that'd be a fun aside. So the other option is we have an upload channel. So we have the LiveView, and then anytime we want to upload files, we have a separate channel, and all the uploads go over that channel. There are a couple issues with this. One is sequentials, and the other issue is, again, a large file could block the channel over the upload channel. So there's another better option that we eventually ended up going with, and that is to have an upload channel per file. So again, we read the files client-side, and for each file, we open a new channel, and we send the binary data over the channel. And then when all the files have been uploaded, we have the refs, and we tell the LiveView, hey, all the files have been uploaded. And then the LiveView will go and gather them all from the individual upload channels, trigger the handle event function on the LiveView, and then at that point, it's up to the user what they do with it. And this has multiple benefits, like the uploads are in parallel, so you can see when each individual file's sending data. And it doesn't block the channel either. So if you've got an event come in over the LiveView, you can still do that and respond to it, and it'll work fine. So this was my reaction when I thought, I was like, oh, this could totally work. Let's try. And it does, spoilers. So the way we implement this, there is 3 elements to it. One is a custom serializer to allow us to send binary data. 2 is we have upload channels. So LiveView channels have like the LV namespace, so arbitrarily I chose LVU. And then the third is to gather the files and trigger the event. So the custom serializer, the serializer is like how Phoenix channels handle the messages that come over the WebSocket. They, up until now, this basically, are all in text format. Typically they're JSON stringified and sent over, and then Phoenix will JSON decode them. And then they're in like this Phoenix socket message struct, and Phoenix channels know how to deal with that. The good thing about WebSockets is that you can determine, you can specify the type of the frame, so you don't have to decide ahead of time this is a binary WebSocket or it's a text WebSocket. You can change it. So we can still use like a text WebSocket for the events that come in, but just use the binary frame for sending binary data. So the decode function, it's using the Elixir match syntax. And we determine here that if it starts with a 0, we can be confident that it's binary and not text, because that would be like a null byte in text, which wouldn't be valid JSON. If that's not the case, then we treat it as JSON, just use the JSON serializer. Decode's a function you have to specify for the ElixirConf serializer behavior. And then once we've determined it's a binary, we then have a version byte. So this will allow us in future like to decode. If we change the format of the binary, we can still decode it. And if it's not a 1, then at the moment, we only have one version, so it's an invalid version. And then I've left this here to show something you can do with the matching syntax that's nice, is you can use a match later in the same pattern match. So for example, on line 28 here, we have the join ref size, which is 1 byte long. And then on line 31, we're using that to fetch that many bytes. So if it returns 6, then we would just fetch 6 bytes, and we would know that's the join ref. And we have 3 things: the join ref, the ref, and the topic. And then everything else we decide is like a frame of binary, which is related to the file. And then here's the ElixirConf message struct. So I wrote this JavaScript, and I want someone to look at it, so consider this like a code review. Phoenix sockets have an encode function, and if it's not a file, then I want to use the existing encode. If it is a file, then there's a custom binary encode function. I have this helpful write binary, which is how you convert a string in JavaScript to like a byte array. I have a to-do in here that's actually not a to-do, which is the UTF-8. Because we're in control of all the things we're sending, we know that we don't need to handle UTF-8, because we'll just not use UTF-8 characters. But if we were to use a more general like encoder, we would probably need to handle UTF-8. But in this case, we don't need to. And then the binary encode function fetches the data it needs from the message, and then it constructs a header, which is the 0, the 1, and then the 3 things we need and their lengths. And this is the way you do this in JavaScript. So you construct a data view, and then you call set uint8 on it. There are various functions. There's like set uint16, and they also take the endianness, but in this case, all the values are 1 byte long, so we can just use set uint8. And then after we've got the header, we can assume that everything else is the file, and we just combine them together and trigger a callback. So that's the serializer. The upload channels are opened per file, as I mentioned. So we ask the LiveView for a file ref, and then we use that to open the channel. We verify the token, and this is how the LiveView channel, the LiveView upload channel can call the LiveView channel to say, hey, I'm going to upload a file, just so you know. And it will handle events that are specific to the file, which is basically like the file payload, and append it to a file. So when you open it, it will open a file handler, and then each time a frame comes in, it will append it to the file, and then at the end, it's closed and sent to the LiveView. And then we have a separate close, because as I mentioned, the plug upload will allocate the space until the owning PID dies, but we don't want that to happen until we know the user's handled the event, which is why we have a separate return and close phase. So here you can see we're fetching the PID from the token, and then we generate a file using the binary write mode, and then we assign the path and the handle. This is a Phoenix channel. It's not a LiveView channel, so the newer assign function wasn't available at this time, which allows you to like merge a map of assigns. But that's since been added to Phoenix, so you can use like the same way you do in the LiveView, where you just assign and pass a map. And then on each frame, we use IO bin write. There are actually 2 write functions on the IO module. One is write, which only works for the text space, and one is bin write, which we need to use in this case. And then at some point, when they ask for the file, we will return the file, close the handler, and return the path. And then there's a separate stop. And then on the JavaScript side, the way you read a file in JavaScript, you use the FileReader API, which is really nice. Said no one ever. So we're also chunking, so we don't send like the whole binary. We send it in chunks, which the size is determined by the server and is configurable. So it's kind of gnarly, but what we're doing is each file gets its own channel, and we just push the file chunks over, and then at some point you'll have uploaded everything, in which case that file's finished, and then if you finished uploading all the files, you can call back to tell the LiveView, hey, we're done, go and get your files. So you see here the chunk size is sent by the server. And then this is just how we chunk, essentially, so we're not sending everything. So once we have all the data serialized and sent over the LiveView channels and the upload channels, we then need to gather all the files from the refs that we get over the LiveView. So this will also be serialized along with any other form data. So if you imagine you've got like an avatar and a name in there, then the name will have the name as a string, and then the avatar will have like a struct, which is the uploaded file. So we need to walk the data that we've received. The form data will be in one piece of the payload, and the file data will be in another. And we walk the file data and merge it in with the params that come in and add the path. And at this point, we've got everything we need to trigger the event, and the user can handle it. And then after we're done, we need to stop all the upload channels so that they release the files. So here we have the data that comes in on the payload, which is the LiveView channel. And then this is the way we ensure that the channels get closed. So we use a try and then an else, which allows you to match on the result of the try. And then we say after, go through all the channels and stop them. So that's how we ensure that they're stopped every time. So we could probably do a demo. Let's see. There we go. So this is like the kitchen sink demo for Phoenix LiveView. It's just got everything. I wasn't going to demo this, but I'll spoil you. This is the counter. There you go. Great. So we have the file uploads here. We can just choose the files. There's one file, another file. And if we inspect the frames for the payloads here, when I hit save, you see that the first one was a small file, so uploaded really quickly, and then the second one's got the progress handler that goes up. And then there's, again, one image. And there's me wearing children's goggles. And if you observe really closely, you'll see that my eyeball is being sucked out of my face. It was really uncomfortable. You can also see the shape of my head is being distorted. Like it's, yeah. And if we look at the data here, we have the binary message uploads in roughly 64K chunks. And then each one of these events is just the progress that changed. So that's just a figure, like a number that comes back. And then that was what changed the upload progress bar. So it works. So the way the progress works is you can determine, because we're sending the chunks, we can just know how much has been sent. And for each chunk we send, we then, over the LiveView, say, hey, this is how much has been updated, has been sent, and this is the total file size. And from that, you can determine the percentage of the upload. We deliberately chose to send the events over the LiveView client side. We could have done it server side because we know where the LiveView is, where we could have had an event there. But if we do it client side, it allows us to send progress events if we have other upload mechanisms that maybe aren't on the same node. So here's the progress counters. They get initialized to 0. And then as they're rendered, you can work out the total by taking each individual percentage and dividing it by the total number of uploads. And then there's an HTML progress bar that takes a max and a value. So here we're using max of 100 to represent a percentage. And then we have the upload event. So you can add a PHX upload event to an imp file input. And if you have that set, then it'll trigger the handle event with that as the event name. If you don't, then you won't get these events, but that's fine because you didn't want them, otherwise you'd have added it. And you can match on whichever field you want. So in this case, we're matching on the avatar, and we say the progress is, the done over the total size times 100, which is such a common pattern that we've actually just also added the percentage in there. And each time this event gets triggered, it will re-render, and that's how the progress bar updates. One thing I didn't show is that you can do validation. So when you select a file from a file input, you can then read the metadata about the file. So you can get like the MIME type, the file size, things like that. So this allows you to do some basic client-side validation. Well, it's client-side, but you write it on the server, but it's essentially client-side. So in this case, we're saying the size. This is like a naive size check. It's naive because it's sent from the client, so someone could change it and say, hey, this 1 gig file is actually only 100K, and you'd accept it, but we have something for that. And the other one is a terrible way to check the image is like a JPEG, but you can do that. Maybe you have like a list of MIME types you want to check. So that's what works. What doesn't work is this only works over WebSocket, so if you're using like the long polling feature of Phoenix channels, this isn't going to work for you. Maybe do your uploads some other way. And the other thing that doesn't work, but I saw potential for when I was implementing, was processing the file as it's being uploaded. So it's not something you can do because the file needs to be available for the event, but you could write similar code that maybe you have a CSV and you want to parse it as it's coming in. Where I was like appending to the file, if you did something different there, you could totally parse a CSV. So maybe there'll be a way to like allow you to change the upload mechanism. I haven't added this here, but it's probably worth mentioning. It doesn't work offline. If you're trying to upload your file without an internet connection, it's not going to work. So just caveats. There are a few problems with the implementation that I want to talk about. So one is like we're just opening one channel per file. You could end up with a lot of channels and a lot of files being open on the node. As I mentioned, you can spoof the file size because it's just sent by the client. And the other thing you can do is like you can open a channel and upload a bit of a file and then just leave it open. And that's kind of similar to the max concurrent uploads issue. So for the max concurrent uploads, what we can do is have, so the problem is like a malicious user could just open up, tons of, like 1 million channels, and then that would open up 1 million file handles, and they would just be eating space in the file system. But this problem isn't like exclusive to this. You could also do this with HTTP uploads and just do the same thing. But you can fix this with like application level solutions, like you can have rate limiting if you use not ETS on one node, or you can have like require the user to authenticate before they can upload a file. That's kind of application specific. But one of the guards we put in place in the LiveView uploads is to have a configurable max number of concurrent uploads per LiveView. And then we can validate this client side because you know your file inputs. So you can say, well, you've given me 5 files, but you're only allowed 3. Something bad's happened. But again, that's client-side validation. So the other thing you can do to protect against this is, which we do, which is server-side. When you open a LiveView upload channel, we ask the LiveView, hey, how many uploads have you got going on? And if it's more than the limit, we'll just close the channel again, and it'll be rejected. But like I said, this can be checked client-side as well, so you can handle it before it happens. The other issue is someone changing the file size. The way to fix this is we have a configurable file size limit. So yeah, you can check on the validation event to show an error to the user, but if they lie, because some people lie on the internet, we check how many bytes have been uploaded, and then if at some point it exceeds the limit, we just stop the channel, close it off. We don't allow it. And the third issue is it's essentially the Slowloris attack, where you open a connection and you just drip bytes down the connection without closing it. So here, in this case, you'd start uploading a file and just never finish. And we can have a fix here, so we can have like an idle timeout, and if we've had no activity on the channel, then we'll just time out and close the channel. And the other thing is we know the chunk size that we're expecting, so if we're saying the chunks are going to be 64K, and we get a much smaller chunk several times, we can say like something bad's probably happening here, and again, close the channel. So maybe you've been sat here thinking, this sounds great, I don't care. I use S3 uploads because I'm sensible, like an adult. And I too use S3 uploads. And the way this works is you can ask S3 for like a signed URL, which is like a one-use URL that you can upload to. And you set that as your upload target, and you upload the file straight to S3. It never touches your server. And then when it's finished, you have the path where it is in the S3 bucket, and you can go and fetch it. So we have plans to support S3 uploads in LiveView, maybe not in LiveView directly, but some way of doing it, like a plugin of some sort. And the way this would have to work is it would have to ask the LiveView for the signed URL, and then at the point of uploading, instead of uploading over the upload channel, we would upload to the signed URL. We could still send the same progress events, which is why we chose to do it client-side, because we can use like the progress on the XML HTTP request API and just send that the same way we do at the moment. So then you could change your upload mechanism, but you wouldn't have to change your LiveView for the upload progress. And then when we're finished, instead of sending the path where it exists on the file system, we'll tell you somehow where it exists on the S3 bucket. And you'll already know which S3 bucket it is because that'll be where it's uploaded to, and you'll have told it where to upload to. So that's kind of where we are today. There's a few things that we need to do. I started this feature a few months ago, and then I stopped working on it for a while. But LiveView didn't stop working. So when I came to merge in my changes, I had to do a rebase with like all the LiveView JavaScript changes in the one JavaScript file that exists for LiveView. And it was really fun. But I've done that now, so I've added a few more features since then. One of the things we need to add is error checking. I don't mean like validation, I mean like the LiveView needs to monitor the upload channels, and the upload channels need to monitor the LiveView. And this will allow us to, allow the LiveView to know that the upload channel's crashed, and then it can reduce its count that it maintains for how many files are concurrently being uploaded. And also we want the LiveView, if the LiveView crashes, we want the LiveView upload channels to stop. They're not needed anymore. I need to do documentation. There's not going to be a huge amount of work in the documentation, I don't think, because it's like exactly the same as the validate and save events we already have. It's just the type of the file, like the value you get there won't be a string, it'll be some sort of struct. As I mentioned, plugins, like S3, but maybe you have other upload mechanisms that work in different ways. We need some way to support it, ideally, so that all uploads aren't going over WebSockets. And more generally, like this has got some of a binary protocol, but it doesn't have everything you would need to use a binary serializer for all Phoenix channels. So we could do something that encodes all the terms that you can get bidirectionally, all the terms from JavaScript to Erlang in a binary format, and then vice versa from the server to the client in a binary format as well. And the next point, you'll notice it's crossed off. That's not because I finished it. That's because I'm not sure. So we don't really have a drag and drop story in LiveView at the moment, but it's a common use case in file uploads that you can just drag a file into a drop target, and then it'll just start the upload automatically. And that's something that if we have any drag and drop support, we could have like a form with one file input that automatically submits when you drag the file to it. So potentially there's something that could happen there. And then again, you just have the upload progress events happen, and you could use hooks to like store where your progress is on the client. So that's it. Thanks for listening.